Good morning, students. Welcome to NIRMALYA Academy. Today we will discuss about polynomials. The general form of a polynomial is polynomial in variable x equal a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 up to an, where n is a positive integer and a0, a1, a2, an are real numbers. So this is the general form of a polynomial. Next thing, degree of polynomial. तो डिग्री क्या है? This is the highest power of variable in a polynomial. This is the highest power of variable in a polynomial is known as degree of polynomial. Let us take an example. A polynomial in variable x or p of x equal 2x to the power 3 minus x square minus 5x plus 3. Here the highest power of variable x is 3. The highest power is 3. The highest power of variable is 3. Therefore, degree of polynomial px is 3. Just like we can take another example. Polynomial in variable y. Py equal 5y square minus y plus 7. Here the variable is y and its highest power is 2. So the degree of polynomial polynomial in variable y is 2. Next we will see types of polynomial. First one, linear polynomial. Linear polynomial. What is a linear polynomial? The linear types of polynomial. First one is the linear polynomial. The linear polynomial क्या है? A polynomial of degree 1. A polynomial of degree 1 is known as linear polynomial. And its general form is ax plus b. The linear polynomial का general form ये है ax plus b, where x is a variable, and a and b they are any real numbers. For example, 5x plus 3. This is a linear polynomial. Here the highest power of x is 1 or its degree is 1. That's why it is a linear polynomial. Just like it is 2x, it is also a linear polynomial. Here b is 0. A is 2 but b is 0. Because it can be written as 2x plus 0. Means ये हो गया ax plus b. Where a equal to and b equal 0. So that's why it is also a linear polynomial. So these are the linear polynomial and their general form is ax plus b. Next, quadratic polynomial. Quadratic polynomial. This is a polynomial of degree 2. A polynomial of degree 2. A polynomial of degree 2 and its general form is ax square plus bx plus c, or we can write it as px equal x square plus bx plus c. This is a polynomial of variable x. The px, or we can write it as px equal ax square plus bx plus c. So this is the general form, and the highest power of variable is 2. On replacing ABC by real numbers, we can write it as 3x square plus 2x plus 7. So this is also an example of quadratic polynomial. Here the highest power of variable is 2. Just like you can write as 5x square minus 3. It is also a quadratic polynomial. Here b is 0 because it can be written as 5x square plus 0 into x plus minus 2. So it is also a quadratic polynomial. So these are the example of quadratic polynomial. Next, third one, the cubic polynomial. Cubic polynomial, that is a polynomial of degree 3. Cubic polynomial is a polynomial of degree 3. And its general form is ax cube plus bx square plus cx plus d. Here the variable x, here the variable is x and its highest power is 3. So that's why it is a cubic polynomial. Another example, example 2x cube minus 5x square plus 3x plus 7. So this is a cubic polynomial and the highest power of the variable is 3. Next, fourth one, biquadratic polynomial. Biquadratic polynomial. That is the polynomial of degree 4. A polynomial of degree 4. And its general form is ax to the power 4 plus bx cube plus cx square plus dx plus e. Just like this. This is a biquadratic polynomial, or this is the general form of biquadratic polynomial. Next, we will discuss about the geometrical meaning of polynomials. Geometrical meaning, the first we will see about the geometrical meaning of linear polynomial. The linear polynomial जिसका general form ax plus b था. If we see its geometrical representation, then we should try to understand it with the help of an example. Y equal 2x plus 3. This is a linear polynomial. Y equal 2x plus 3. 2x plus 3. This is a linear polynomial. And if we represent it on graph, then it will be a straight line. You have already known about it in class 9. The graph of a linear polynomial is always a straight line, and this straight line will intersect or cut the x-axis at exactly one point. The graph of the linear polynomial always intersect the x-axis at exactly one point, and that is the zero of that linear polynomial. We have already learned about the zeros of the polynomial. Zeros means Zero. What is the meaning of zeros of a polynomial? It is the value of the. It is the value which makes the polynomial zero. For example, if we want to know the zero of polynomial 2x plus 3, 2x plus, we have to write like this: 2x plus 3 equals 0. That implies 2x equal minus 3 or y equal 0. That means x equal over minus 3 by 2. So the value of x over minus 3 by 2, or it lies between minus 1 and minus 2 because it equal minus 1.5. In this case, y will be 0 because only in this case x coordinate is there but y will be 0. So there is only one point or only one zero for a linear polynomial. So linear polynomial का एक ही zero होता है and it intersects and it is the point that lies on x-axis. In the same way, for a quadratic polynomial, if we see for a quadratic polynomial, the graph of y equal ax square plus bx plus c. Y equal ax square plus bx plus c. So the shape of the graph of y equal ax square plus bx plus c follows the three cases. What are the three cases? The first situation, case 1, in this case, the graph cuts the x-axis at two distinct points. So these are the two distinct points, but there are the two zeros for a quadratic polynomial. So it may be like this, or this is called upward parabola, or it may be a downward parabola. Downward parabola. Just like this. So this is the first case. The graph got x-axis at two distinct points. Means there are two zeros for the quadratic polynomial. Case 2. Next case 2. In second case, the graph got axis at exactly one point. The graph got x-axis or the parabola got the x-axis at exactly one point. I mean, in this case, there are 2 points. The 2 points coincide, or they are the coincide points. They are the coincide points. In this case, we can say that there is exactly one point, or the graph got the x-axis at exactly one point, or the 2 points coincide. Actually, there are two zeros or 2 points which coincide. Two points coincide. So that's why the graph got the x-axis at exactly one point. This is the second situation. Third situation, in this case, the graph is either completely above the x-axis or completely below the x-axis. That means the graph does not intersect the x-axis at any point. The graph is completely above the x-axis or completely below the x-axis. It may be like this or just like this. In this case, the quadratic equation has no zeros. It has no zeros. So these are the geometrical meaning of the polynomials. Next, now we will discuss the relationships between zeros and coefficients of a polynomial. Relationship between zeros and coefficients of a polynomial. of a quadratic polynomial, basically quadratic polynomial. Let's take example of quadratic polynomial. Px equal x square minus 5x plus 6. So this is the quadratic polynomial. So now we want to know the relationship between zeros and coefficient. The zeros, first we have to find the zeros of the polynomial. So zeros means that matches the zero to the polynomial. So let x square minus 5x plus 6 equal 0. So once splitting the middle term, we get x square minus 3x minus 2x plus 6 equal 0. This is the middle term splitting. So then taking common x into x minus 3, then minus 2 into x minus 3, that equals 0. That implies x minus 3 into x minus 2 equal 0. So that implies x minus 3 equal 0 or x minus 2 equal 0. That implies x equal 3 or x equal 2. So there are two zeros for the given polynomial, 3 and 2. So now actually now we find the sum of zeros of the polynomial. Sum of zeros that equal over 3 plus 2. One zero is 3 and another is 2. So their sum will be 3 plus 2 equal 5. So that equal minus, actually the sum of zeros for a particular polynomial is always minus b by a. As you know, the general form of polynomial is ax square plus bx plus c. Let its zeros be alpha and beta. Let its zeros be alpha and beta, because there are only two zeros for a quadratic polynomial. So their sum is always alpha plus beta equal minus b by a. So for our example, x square minus 5x plus 6, in this case it can be written as minus b by a, that equal minus into minus 5 by a, that is 1. But the relation is minus into, this minus 5 is the coefficient of x, this is the coefficient of x, so it can be written as minus into coefficient of x divided by coefficient of x divided by 1. 1 is the coefficient of x square. This is the relationship between zeros and coefficient. This is the first relation. Second, product of zeros. Product of zeros. 3 into 2, that equals 6. So actually, for a quadratic polynomial, product of zeros, if its zeros be alpha and beta for x square plus bx plus c, then let's its zeros be alpha and beta, then product of zeros alpha into beta is always c by a. So product of zeros 3 into 2 is 6, 3 to the 6, that equals 6 by 1, because 6, so 6 is the constant term. For example, in our example, x square minus 5x plus 6 is constant term and 1 is the coefficient of x square. So it can be written as constant term divided by coefficient of x square. So we came to know that the relationship between zeros and coefficient of quadratic polynomial. So the basic point is that sum of zeros for a quadratic polynomial ax square plus for a quadratic polynomial ax square plus bx plus c. If its zeros are alpha and beta, then sum of zeros alpha plus beta is always minus b by a, and product of zeros alpha into beta is always c by a. So again, if you know sum of zeros and product of zeros, then you can write the polynomial also. So that is quadratic polynomial equal x square minus sum of zeros, that is alpha plus beta into x plus product of zeros alpha into beta. For example, suppose it is given that alpha plus beta equal, example, alpha plus beta equal 4 and alpha beta equal 3. Then the quadratic polynomial will be x square minus 4x plus 3. On replacing alpha plus beta and alpha into beta, we get x square minus 4x plus 3. Just like this. Now let us see the relationship between zeros and coefficient of a cubic polynomial. As you know, the general form of cubic polynomial is ax cube plus bx square plus cx plus d. Let its zeros be alpha, beta and gamma. Let its zeros be alpha, beta and gamma. Then sum of zeros alpha plus beta plus gamma is always minus b by a. Sum of zeros alpha plus beta plus gamma equal minus b by a. Then product of zeros, product of two zeros, twice two zeros taken at a time. Suppose alpha into beta plus beta into gamma plus gamma into alpha. Product of two zeros taken at a time, that equal over c by a, that equals c by a. Then product of zeros, that is alpha into beta into gamma, that equal over minus d by. Now we take an example. Take an example. Let px equal 3x to the power 3 minus 5x square minus 11x plus 3. Here a equal 3, b equal minus 5, c equal minus 11 and d equal 3. These are the values of a, b, c and d. Now alpha plus beta plus gamma, that is the sum of zeros, that equal minus b by a. So that equal over minus into minus 5 by 3, because b is minus 5. So minus b, that means minus into minus 5, that equal 5 by 3. So here sum of zeros is 5 by 3. Next, product of two zeros taken at a time, alpha into beta, beta into gamma plus gamma into alpha, that equal c by a. Here the value of c is minus 11 and a is 3, so that will be minus 11 by 3. Then product of zeros alpha into beta into gamma, that equal minus d by a. Here d is 3, so minus d by a, that will be minus 3 by 3, that equal minus 1. Next, division algorithm for polynomials. Division algorithm for polynomial. for polynomials. If px and gx are any two polynomial with gx is not equal 0, then we can find the polynomials qx and rx such that px equal gx into qx plus rx. If px and gx are any two polynomials, then we can find polynomials qx and rx such that px equal gx into qx plus rx. So this is the division algorithm for polynomial. और हमको दो पोलिनोमियल px एंड gx पता है, तो और दो पोलिनोमियल qx एंड rx पता कर सकते हैं such that px equal gx into qx plus rx, where rx may be 0, rx equal 0, or its degree may be less than degree of gx, or degree of rx is less than degree of gx. Let's take an example. let px equal x square plus 7x plus 10. Then gx and gx equal x plus 2. Now on dividing x square plus 7x plus 10 by x plus 2, we get x first. We multiply x plus 2 into x, that equal x square plus 2x. 7x minus 2x, so we get 5x plus 10. Then we will take 5. 5 into x, 5x plus 5 will take. Then it will be 0. So the qx is x plus 5 and rx is 0. In this case, rx is 0. So we can write px equal gx into qx plus rx, that is x square plus 7x plus 10, that equal x plus 2 into x plus 5 plus 0. Next, when two zeros of a cubic polynomial, of a biquadratic polynomial are known to us, and we have to find out the other two. Two zeros are known, and we have to find out the other two zeros. Let's take an example. Find all the zeros of polynomial in variable x. Px equal 2x to the power 4 minus 3x to the power 3 minus 3x square plus 6x minus 2. 2x to the power 4 minus 3x to the power 3 minus 3x square plus 6x minus 2. So this is the polynomial. If two of its zeros are root 2 and minus root 2 and minus root 2. Now first of all we have to find the factors. You know factor theorem. If factor theorem states that if PA equals 0, then x minus a is a factor of px. This is a factor of px for polynomial in variable x. Suppose for any polynomial px equals suppose x minus 1 and pa equals 0, then x minus a is a factor of px. For example, in this case, if we take x equal 1, then it will be 0. So here p1 equals 0, here p1 equals 0. If we take x equal 1, the value of px will be 0. So x minus 1 is a factor of px. In this way, since root 2 and minus root 2 are the two zeros of the polynomial, so that's why x minus root 2 into x minus root 2, that is x plus root 2 is a, ये दोनों फैक्टर है, उनका प्रोडक्ट भी एक फैक्टर होगा. सो दिस इज ए फैक्टर ऑफ px और x minus root 2 into x plus root 2, or it will be on applying identity x a minus b into a plus b, we get s square minus b square, that is x square minus root 2 square, that is called x square minus 2. This is a factor of px. This is a factor of px. Now, on dividing px by x square minus 2, we get 2x to the power 4 minus 3x cube minus 3x square plus 6x minus 2 divided by x square minus 2. So here the first term is 2x to the power 4 and on divisor the first term is x square. So the first question will be 2x to the power 2. So it will be 2x to the power 4 minus 4x square. On subtracting, minus plus for x square minus 3x square, it will be only x square. This is minus 3x to the power 3 plus x square plus 6x minus 2. Next, the first term is minus 3x cube and on divisor the first term is x square. So the question will be minus 3x. So it will be minus 3x to the power 3 plus 6x. So I am subtracting x square minus 2. The remainder will be x square minus 2. Next, here the first term is x square, on divisor also x square. So we will take 1. So 1 into x square minus 2, that will be x square minus 2. So the remainder is 0. So next we can write px equal gx into qx plus rx, that is 2x to the power 4 minus 3x to the power 3 minus 3x square plus 6x minus 2 equal x square minus 2. This is our gx into qx, that is 2x square minus 3x plus 1 plus rx, that is 0. So next, x square minus 2 into 2x square minus 3x plus 1. Now we will factorize it. On splitting the middle term, we get 2x square minus 2x minus x plus 1. So that equal x square minus 2 into taking common 2x, common is 2x, we will get x minus 1 minus 1 into x minus 1. So that equal x square minus 2 into x minus 1 into 2x minus 1. So next thing, this is the px, or the value of the given polynomial is equal 0 when this equal 0. That is when either x minus 1 equals 0 or 2x minus 1 equals 0. So the value of px equal 0 if x minus 1 equal 0 or 2x minus 1 equal 0. That implies x equal 1 or x equal 1 by 2. So all the zeros of the 2x to the power 4 minus 3x to the power 3 minus 3x square plus 6x minus 2 are, so all the zeros, therefore all the zeros of 2x to the power 4 minus 3x to the power 3 minus 3x square plus 6x minus 2 are root 2 minus root 2 comma 1 and 1 by 2. So these are the all the zeros of px, or 2x to the power 4 minus 3x to the power 3 minus 3x square plus 6x minus 2. Okay, thank you.